In this video, we're talking about piecewise defined functions and how we evaluate them. So we start off with this guy. He's a pretty big guy. He's got three pieces to him. You have negative 5x plus 7 for values of x that are less than or equal to negative 7. Then you have that the function is equal to x squared plus 3x if x is between negative 7 and 2. And then your function is 9x minus 1 if you're plugging in values of x that are greater than or equal to 6. Now, I know that a lot of times these piecewise defined functions can be kind of overwhelming, but they don't need to be. What you need to remember is that, as with any function, if you plug in one value, you get out one value. You don't get out three values here. Even though it has three pieces, um, you don't use them all at the same time. You use these conditional statements to figure out where your x's go. So if you have an x value that's less than or equal to negative 7, you plug it into this expression. If x is between negative 7 and 2, you plug it in here. And if you have an x value that's greater than or equal to 6, it gets plugged into this expression. You don't plug it into all of them. You use these conditions to figure out where the x's go. So here's what I like to do. Sometimes I'll just take an extra piece of paper like this, and I just draw a number line. And I pay attention to these critical values here. So we have negative 7. We see that we're using 2 as well. And we also have 6. So I'm going to color code these. This guy here is going to be my pink one. And it says for x is less than or equal to negative 7. So if you had to graph this on a number line, that would be using a bracket here at negative 7 and going to the left. So I'm going to do that here in pink. And above this, I'm going to write what the function is, which is negative 5x plus 7. So using this number line, it's going to help me, because if I have any value that lies on this part of the number line, it's going to get plugged into that pink expression. That's it. And then I'm going to use blue for this one here in the middle. So this is between negative 7 and 2. Notice how these guys are not being included because of the inequalities. So it's going to be parentheses from negative 7 to parentheses 2. So any number that falls in this region of the number line will get plugged into the expression x squared plus 3x. And I hope that you'll see that there won't be any overlapping of these intervals that I'm drawing. Okay, so whatever value you have, it's only going to fit in one of these regions. It can't fit in multiple ones. It just doesn't work that way. Because if it did, then you wouldn't have a function, and we'd be in trouble. All right, so let's use green for this last one. This is greater than or equal to 6. That's going to be a bracket here at 6 and going to the right. So any value, any input value that is greater than or equal to 6 gets plugged into this expression, 9x minus 1. So for each of the 4 evaluations that we need to do, you need to figure out, do I plug it into the pink, the blue, or the green region? Or something else, does it fall in this region where you have no definition for it? In which case, that means the function would be undefined for that input value. All right, so let's see what we have. Looking here, we have f of negative 15. I guess I can slide this out of the way. So negative 15 is over here in this region. So here is negative 15. So negative 15 is under this pink area. And so that's the piece of the piecewise defined function that I'm going to use to evaluate this. So this is equal to, it's in the pink region, so we might as well use our colors. So this is negative 5. Replace the x with the input value of negative 15 and plus 7. Right? So just do the math here. Negative 5 times 15 is 75 plus 7, and 75 plus 7 is 82. Now, I have a lot of students that get kind of thrown off here and they say, wait a minute. You get 82, but this piecewise defined function says less than or equal to negative 7. Well, pay attention to what you're doing, okay? So your input, okay, so this guy right here, this is x. This is your input value. The input value is what you use to figure out what region it falls into and what piece of the function you use. So my input value was less than or equal to -7. This 82, this is my corresponding y value. This is my output. And none of these statements over here have anything to do with what the output's going to be. There's nothing here that says, oh, your output has to be less than -7 or it has to be greater than anything. No. You plug in this value for x and you get y. It just is what it is, right? There's nothing to test this against. It's just you get 82. All right, let's see f of 4. So if I look at 4 and I look here on my number line, you see that 4 is right about here. So 4 is not under the pink, the blue, or the green region. That means that this function is not defined for an input value of 4. If you look at the original piecewise defined function, none of these regions include an input value of 4. So that means we can't do this. We can't plug it in. So f of -4, we simply say is undefined. Okay, because the function is not defined for input values between 2 and 6. All right, let's see what else we have. All right, f of 21. So if we look at our number line that we made up here, 21 is going to be way over here to the right. It's going to fall in this green region. All right, so I'm going to use this expression to evaluate my function. So this is 9 times 21 minus 1. All right. So let's see. 9 times 21 is 189 minus 1 gives us 188. So I hope you see that the trick here is figuring out what piece of the function to use and you just plug it in. I'm not plugging 21 into the blue expression or the pink one because that's not where values of x like 21 go. They go over here in this region because 21 is greater than or equal to 6. And finally, we have f of -5. So -5 is in this region. It's between -7 and 2. So it falls under the blue umbrella. So using this blue expression, so it's going to be parentheses, -5 squared plus 3 times x. So x again is the input value of -5. So we work this out. Positive 25. 3 times -5 is -15. Combine, and we have positive 10. So I think it's very helpful to draw a number line like this, and you put the regions above with the corresponding expressions so you know where everything goes. And it makes evaluating these functions, these piecewise defined functions, a piece of cake.